So hello all. The next topic which we are going to discuss is QR decomposition. Okay. So if suppose A is an n by n matrix with linearly independent column vectors, and if Q is a matrix with its orthonormal column vectors, then is there any relationship connecting this A and Q? That is what the question is. Yes, there is a relation connecting this A and Q, that is the A matrix A, which is of order m by n, can be written as Q into R, where this Q is nothing but an orthonormal column vectors. It's a matrix with orthogonal column vectors, and R is nothing but an n by n invertible matrix. Okay, so let us discuss this with an example. So here A can be written as Q into R, where Q is nothing but a column vectors which we obtained with the help of the Gram-Smith process, and R is nothing but an invertible upper triangular matrix. So this is how the R will look like. So R will be equal to inner product U1 Q1 U2 Q1 etc. U1 Q1 in the first row, and 0 u2 q2 etc. un q1 un q2 in a product in the second row, and it will goes on till its end. Okay, so this process is called as an QR decomposition. So this is the theorem statement for this QR decomposition. A is any m by n matrix with linearly independent column vectors, then A can be factored as A into Q, Q into R, where Q is an m by n matrix with orthonormal column vectors. R is an n by n invertible upper triangular matrix. Okay, so example, find QR decomposition of A is equal to 1, 1, 1, 0, 1, 1, 0, 0, 1. So these are nothing but the UI values which is given to us in the previous sum. Okay, which we discussed under the Gram-Smith orthogonalization process. So take the individual columns as u1, u2 and u3. So this is our first column will be our u1, sorry, just a minute. So this is our u1 column, this is our u2 column. Similarly, the last will be our u3 column. So take it like this. And we have applied Gram-Smith orthogonalization process to convert this u1, u2, u3 to an orthonormal basis, and q1 and it left as the value for q1 as 1 comma 1 by root 3, 1 by root 3, 1 by root 3, q2 as this and q3 as this. So we need to write this i's in each column to obtain the value, obtain the q matrix. So that is what we have written it here. So this is your q matrix. And to write R, the formula to calculate R as the R matrix will be of this form. So you need to take inner product with this u1 and q1, so that we will be getting when you take inner product between this u1 and q1, u1 comma q1, so the formula is you need to multiply first element with first element. So 1 by root 3 into 1 is 1 by root 3 plus 1 by root 3 plus 1 by root 3. So the denominators are the same. So you need to sum up the numerator, leaving us 3 divided by root 3. Similarly, u2 with u2 with the q1. So u2 with q1, in the sense the first will be 0. 0 plus 1 by root 3 plus 1 by root 3, that gives you 2 by root 3. And u3 is 0, 0, 1. When you take inner product between this u3 and q1, you will be getting just 1 over root 3. And here this is 0, and the inner product between u2 comma q1. So you need to take inner product between these two guys. So you will be getting 0 plus 1 by root 6 plus 1 by root 6. So you will be getting 2 by root 6. Similarly, when you take inner product between this u3 and q2, you will be getting 0 plus 0 plus 1 divided by root 6 is 1 divided by root 6. And the last row is 0 0 and u3 comma q3. So u3 comma q3 in the sense 0 plus 0 plus 1 divided by root 2. So that gives you the answer. So this gives the matrix R. So when you multiply this q and r, we will be obviously getting the value for A, and here ends the concept of QR decomposition. So let us do one problem under this QR decomposition again. Okay, find QR decomposition for the matrix. Find QR decomposition for the matrix A, that is equal to 1 minus 1 2 3. So as I told you already, so this is your u1 and this your u2. So u1 is nothing but 1 2 and u2 is nothing but minus 1 3. So when you take dot product between these two, it is not 0. So the u1 and u2 are not an orthogonal set. So we need to apply Gram-Schmidt process to convert this into an orthogonal set, and then we need to find the value for orthonormal basis. So we need to apply Gram-Schmidt process, orthogonalization process. So by this, in step 1 you need to take v1 as u1, so that is equal to 1 comma 2, and in step 2 you need to take v2 comma u2. So v2 is equal to u2 minus projection of u2 under this w. So what you will be getting is u2 comma v1 divided by norm v1 square multiplied by v1. So that gives you u2 value is, the value for u2 is given as 1 minus 1 3 minus 1 comma 3 minus the inner product between u2 comma v1. So the inner product between u2 and v1 is, when you take inner product between these two guys, you will be getting minus 1 plus 3 2s are 6. That gives you 5 as your answer. So 5 divided by norm v1 square. So we know the value for v1 is 1 and 2. When you take a norm v1, you will be getting root of 1 square plus 2 square, which is 4. That gives you root 5 as your answer. So just do replace it here. You will be getting root 5. So root will not come because it is the value for norm v1. Since it is square, it is just 5. I multiplied by v1. The value for v1 is 1 comma 2. So these two will get cancelled when you subtract minus 1 comma 3 with 1 comma 2. Minus 1 is minus 2. 3 minus 2 is 1. So this gives you the value for u2. So let me take s as v1 comma v2, where v1 is 1 comma 2 and v2 is minus 2 comma 1. Okay, so when you check the orthogonality between this v1 and v2, you will be getting minus 2 plus 2, which is 0. So what we can tell is S will form an orthogonal set. Okay, so S, when you take inner product between v1 comma v2, so you are getting 0 as your answer. So therefore S is an orthogonal set. Next, we need to check whether S forms an orthonormality or not. To find norm v1 and norm v2. So norm v1 is equal to root 5 and norm v2 is equal to root 5 again. Minus 2 the whole square is 4. 4 plus 1 is 5. So both the values for norm v1 and norm v2 are 5. With this we can able to normalize to find the value for qi's. Okay, so q1 is equal to v1 divided by norm v1. So the value for v1 is 1 comma 2 divided by root 5. That gives me 1 divided by root 5 comma 1 divided by 2 divided by root 5. Similarly, q2 will be equal to v2 divided by norm v2. That gives me minus 2 comma 1 divided by root 5. So minus 2 divided by root 5 comma 1 divided by root 5. Okay, so now this q1 and q2 will form an orthonormal basis. So s1 is equal to q1 comma q2. When you take norm and check, you can able to confirm yourself. So s1 will form an orthonormal basis. Okay, so till this it is the process for your Gram-Smith, and next we need to resolve A into Q and R, where this Q is nothing but a column vector of the values which we have obtained from this Gram-Smith process, and R is an n by n invertible upper triangular matrix. Okay, so the value for Q is nothing but Q1, Q2. Q1 need to be written in the first column and Q2 in the second column. So we will be getting 1 divided by root 5 and 2 divided by root 5 minus 2 divided by root 5, and the last one is 1 divided by root 5. That will be the value for our Q. So we need to find the value for R. Okay, we need to find the value for R. So the formula to calculate R is u1 comma q1 in the first row, u2 comma q1 0, and then u2 comma q2. So u1 comma q1, we know what the value for u1 is. u1 is nothing but 1 comma 2. When you take inner product between this u1 and q1, which is 1 by root 5 and q by root 5, will be getting, let me find it out step by step. Inner product between u1 comma q1, so you will be getting root 5 as your answer. So let me check it. The value for u1 is 1 2. We need to take inner product between 1 comma 2 and q1. The value for q1 is 1 divided by root 5 comma 2 divided by root 5. So when you take inner product between these two, you will be getting 1 divided by root 5 plus 2 2s are 4, 4 divided by root 5. So which is 5 divided by root 5. 5 divided by root 5 is nothing but root 5. So in the same way, when you calculate the inner product for u2 with q1 and u2 with q2, so what we will be getting is q is equal to root 5 is root 5 0 and root 5. So hence we can conclude the value for A as q into r. Sorry, this is not q, I have written it wrongly, this is r. The value for q into r, where this q is nothing but 1 over root 5 minus 2 divided by root 5, 2 divided by root 5 and 1 divided by root 5, and this need to be multiplied by root 5, 0, root 5. When you multiply these two and check, you will be getting the value for A. Thank you.